Okay, to finalize the chapter 4, uh, let's cover example 5.4. We have two relay to coordinate overcurrent relay in order to coordinate these two relay. The first one, relay number 1, close to bus B. The city is 1000 to 5. The other one in the same 1000 to 5. Relay number 2. Uh, then the PS for the relay plug setting, which is overload factor. Okay, so the PS is overload factor is equal for this relay is 100%, which is 1. For this relay, PS is given as a 1.25, 125%. Then the operating time characteristic of the relay is the same as given by this table, table 5.3, example 1. It's referred to this table, okay, table 5.3. The next here is mentioned for the, okay, TDS or TMS. TDS, as I mentioned, all the names close to, I mean, many names for this one, TMS, TSM, all available. Equal to 0.3. So this character is selected for this one. Then the discrimination time between relay 1 and 2 is 0.5 seconds. And they said there is a fault at point F mentioned by here. The fault current is 5000 amp. And said, okay, what is the operating time for relay 1, relay 2, and of course TMS for the relay 2. Okay, step 1 for doing and answering such a question, as I mentioned in the class for the previous example in the same way. Step 1, we have to calculate the PSM. Okay, so PSM, plug setting multiplier, for this one is coming on the way as IF times CTR, CT ratio, correct? Then over, if you can remember, I mentioned always 5 times PS, okay? So how can I decipher this 5 PS and why we choose 5? I can explain by here. Okay, assume in this network we have the maximum current for the loading, which is 1000, correct? And then it is at the primary side. So since we use a city, the secondary side must be 5. So this is the reason we choose 5. It means that we don't know what is the nominal load current at the normal condition of the power system. So we choose the maximum possible load for this one. It's coming from this equation, which is the first equation given by this chapter is here, equation 5.5. You can see pickup setting is overload factor, which is PS, times I nominal divided by CTR. Okay, so CT ratio must be there. On the other way, I can explain this one. Assume the nominal current of the system is only 800 amp. Okay, so on behalf of 5, we have to do the CTR ratio 5 times over 1000, which is the CT ratio. It become, let me check, 800 times 5 divided by 1000 is only 4. So on behalf of 5, this become 4. And don't forget, we have to consider the CTR the same as here. Okay, so since sometimes okay, to make it a clear value for the CTR, here the CTR, or always CTR, as you can see here, is times, here it is divide. Okay, we're trying to reduce the current at the secondary. So the CTR condition, based on some references, maybe divide based on some references is times. It depends how you consider it. Is it 1 over something, 1 over CTR, CT ratio as a CTR, or you call it as the same as something I mentioned, the rank, the wise of the CT value, the same as something I mentioned here, 5 over 1000. Okay, consider that one. We should always reduce the current at the secondary since it is a CT. Then Go back to the example. Okay. Uh, so PSM here, PSM is equal, I fault is 5,000, given as 5,000, correct, times CTR. CTR is 1,000 over 5, correct? Then here we don't know the nominal current. We choose the maximum, and then choose the maximum means it is at the primary is 1,000, so it's 5 and secondary times the CTR, and the PS is given as a overload factor 100, so it's 1. Then the final value here is, I can see, this is the wrong one, correct? Yes, this is should be 5 over 1,000, 5 over 1,000. So this 5, this 5, this 1,000, and these zeros, the last one is only 5. So PSM is equal 5 for the relay 1. So using the curve, since there is no curve, is table. So using the table, that's using the table. Where are you, table? The table is here. Okay, so PSM equal to 5. The operating time, based on this one, operating time of the relay equal to 4 seconds. But this one is given as TSM equal to 1. But the given TSM to for selected one for this, okay, for this one is 0.3. So the operation time of relay number 1 equal 4 times 0.3, which is 1.2 second. Okay, as you can see, 1.2 second. Right now, the operating time of the relay 1 is fine. Okay, this is done. Number 2, operation time of the relay 2 is in this way. Operation time of the relay 1 plus discrimination time equal operation time of the relay 2, correct? So relay 1 is 1.2 plus discrimination time is given as 0.5, become 1.7. So we must calculate the uh, TSM for the relay number 2. Since we know the operation time is given for the relay number 2. This is clear. Okay, let me control A, delete. Okay, we should find out the PSM for the relay 2, which is backup of the relay 1, correct? So for this, for this purpose, we have to consider the fault current of relay 1, which is again 5,000 times CTR. CTR is 5 over 1,000, and then